All, welcome to Polyhipster. In this video, we will be talking about hormonal feedback regulatory systems. So let's begin. Feedback control, both positive and negative, is a fundamental feature of endocrine system. Beginning with the negative feedback system, which is a major HPA axis control. Example, thyroid, TRH, TSH axis. While we have very less knowledge about positive feedback system, we will mainly focus on the negative feedback control in this lecture. Feedback regulation also occurs for endocrine system that do not involve pituitary gland, such as calcium feedback on parathyroid hormone, glucose inhibition of insulin secretion, and leptin feedback on hypothalamus. Here we can see that the hypothalamus stimulates pituitary gland through releasing factors, which in turn stimulates other endocrine glands through various trophic hormones. These endocrine glands in turn provide a negative feedback towards the pituitary gland, thereby decreasing the release of trophic hormone, which in turn causes negative feedback on the hypothalamus, and thus the circle continues. If we talk about regulation of secretion, we should different types of factored secretions. These include autocrine, paracrine, and endocrine. Autocrine is where the action factor is on the same cell from which it is produced. For example, insulin like growth factor 1 that acts on many cells that produce it, including chondrocytes, breast epithelium, and gonadal cells. Whereas paracrine is where factors released by one cell act on adjacent cells in the same tissue. Example, somatostatin by delta cells of pancreas, which inhibit insulin secretion from nearby beta cells. Whereas endocrine, as we have discussed, the factors are released directly into the blood and they act on tissues far away from where it's produced. Like endocrine actions, paracrine and autocrine control are difficult to document because local growth factor concentrations cannot readily be measured. Now let's talk about hormonal rhythms. These are affected by seasonal changes, light-dark cycle, sleep, meals, and stress. For example, the menstrual cycle every 28 days, the circadian cycle. Also, the peaks of ACTH and cortisol in the morning and lowest level at night. Recognition of these rhythms is important for endocrine testing and treatment. The patients with Cushing syndrome exhibit an increased midnight cortisol levels when compared to normal individuals, but morning cortisol will be the same as normal. The HPA axis is more susceptible to suppression by glucocorticoids administered at night as they blunt the early morning rise of ACTH. Understanding these rhythms allows glucocorticoid replacement that mimics diurnal production by administering larger doses in the morning than in the afternoon. Many peptide hormones are secreted in discrete bursts every few hours. For example, luteinizing hormone and follicle stimulating hormone. They are sensitive to gonadotropin releasing hormone, intermittent pulses, but continuous GnRH exposure causes pituitary gonadotrope desensitization. This feature of HPG axis forms the basis for using long-acting GnRH agonists to treat central precocious puberty or to decrease the testosterone levels in the management of prostate cancer. It is important to be aware of the pulsatile nature of hormone secretion and rhythmic pattern of hormone production when relating serum hormone measurements to normal values. For some hormones, integrated markers have been developed to circumvent hormonal fluctuations. For example, 24-hour urine collection for cortisol, IGF-1 as biological marker for growth hormone action, HbA1c as an index for long-term glucose control. One must often interpret endocrine data only in the context of other hormonal results. For example, parathyroid hormone levels are typically assessed in combination with serum calcium concentration. A high serum calcium level in association with elevated PTH is suggestive of hyperparathyroidism, whereas suppressed PTH in this situation is more likely to be caused by hypercalcemia of malignancy or other causes of hypercalcemia. That's all for now. See you soon with more videos on endocrinology.